in this first part, we're going to want to find the derivative implicitly. So when we have an implicit equation like x squared plus y squared equals 100, to find the derivative, the first thing we do is to find the differential of each term. So I'm just going to look at this x squared term and take the differential of that. The differential of x squared is 2x with a dx after it. Next, I'm going to go over to the y squared and take the differential of that, which will be 2y dy. Finally, go to the other side of the equal sign, take the differential of 100, and since that's a constant, its differential is going to be 0. Now we just perform some algebra to rearrange this so that it says dy over dx. So what I'm going to do is subtract this entire term from both sides. That'll give me 2y dy is equal to negative 2x dx. Then, since we're multiplying in both of these places, I'm going to divide. I want to get the dx onto the left side, so I'm going to divide both sides by dx to get this one to cancel. Then I also want to get that dy dx alone, so I'll also have to divide by 2y. Then we'll be finished with dy dx is equal to negative 2x over 2y. Simplify that a little bit too. These 2's will cancel. So dy dx, the derivative, with respect to x, is equal to negative x over y. In part B, we're going to find the derivative implicitly again, but we have to recognize that this 3xy is a product, so we're going to have to use the product rule. And what I'm going to do is kind of split this up into its two factors, 3x and y, and then I can use the product rule to find the differential. The product rule, remember, is 1d2 plus 2d1. So 1 is 3x. d2, that's the differential of y. Well, the derivative of y is just 1, so the differential is 1 dy. 1d2 plus 2d1. 2. The differential of 3x is 3 dx. There we've used the product rule on the left-hand side. Now go over to the right-hand side of the equation, take the differential of that, negative 4 dx. The rest is just algebra, and what I want to do is keep all the dy's on one side and all the dx's on the other. And now it doesn't matter which side I put them all on, so I'm going to add 4 dx to both sides. And what that will do, I'll still have this 3x dy, but these two terms both have a dx in it. So I'll factor out that dx and be left with 3y plus 4 dx. And we're left with nothing on the other side. So I'll bring the dy part, that dy term here, over to the other side by subtracting it. So we'll still have that 3y plus 4 dx. And just on the other side, we got negative 3x dy. Now it's a matter of just rearranging. So I'm going to divide both sides. I want to have dy dx. So I want to have dy dx over here, which means I need to divide by it on both sides, getting it to cancel on the left. I also want dy dx to be alone, so I'll divide by the negative 3x here to get these two to cancel. And then we can see that our dy dx, our derivative, is going to equal this part right here, 3y plus 4 over negative 3x.